Tonight, we are going to drift very slowly into the largest empty place ever discovered. Settle into your bed. Let your shoulders fall away from your ears. Let the weight of the day go. There is no rush in what we are about to do. There is no urgency in any of it. The story we are going to follow took almost 14 billion years to unfold, and we have all night to listen to it. The place we are traveling to is not on any old map. No ancient sailor ever charted it. No constellation was ever named for it. For nearly all of human history, this place was completely invisible to us. It still is, in the ordinary sense of seeing. It cannot be photographed in the way a galaxy can be photographed, because it is not made of stars, or gas, or dust, or planets, or any of the warm, familiar things we usually call space. It is not a thing at all. It is the absence of a thing. It is a region of the universe so wide and so empty that if our entire Milky Way galaxy were suspended at its very center, we would not have known that other galaxies existed until very recently in human history. We would have looked up at our own familiar stars, and beyond them we would have seen only darkness. Endless, untextured darkness, stretching outward in every direction, all the way to the faint limits of what our telescopes could reach. We would have believed our galaxy was alone. We would have written the entire universe in the language of our own quiet pinwheel of stars. It is called the Boötes Void. It lies far above the plane of our galaxy, in the direction of the constellation Boötes, the Herdsman. On a clear summer night in the northern hemisphere, you can step outside and find that constellation almost without trying. Its brightest star, Arcturus, is one of the brightest stars in the entire sky, an old orange giant burning low in the spring evenings. Find Arcturus and let your eye drift up. The shape of Boötes rises above it, sometimes called a kite, sometimes called an ice cream cone, a long, thin diamond of stars stretching upward into the dark. The Boötes Void lies somewhere in that direction, but vastly, impossibly farther than any star you can see with your eye. The stars of the constellation are only a few dozen or a few hundred light years away from us. The Boötes Void begins around 700 million light years from Earth, and it is itself more than 330 million light years across. 330 million light years. Hold that distance in your mind for a moment, gently, the way you might hold a smooth stone. We will return to it many times tonight, and each time it will feel a little larger, a little stranger, a little harder to comprehend. But the story does not begin with the void. It begins with a young astronomer in the quiet years at the start of the 1980s, who set out to make a simple map of the sky, and instead found a hole in the universe. His name was Robert Kirshner. He was working with 3 colleagues, August Olowin, Paul Schechter, and Stephen Shectman. They were in the middle of what was, at the time, a fairly ordinary scientific project. They were measuring the redshifts of galaxies. Redshift is one of the gentlest ideas in modern astronomy, and one of the most powerful. When light travels through an expanding universe, the wavelengths of that light are stretched. Blue light becomes a little redder. Red light becomes a little redder still. The farther a galaxy is from us, the more its light has been stretched on the long journey here, and the more red-shifted it appears. By measuring exactly how red the light has become, an astronomer can tell, with quiet precision, how far away the galaxy is. Redshift turns the night sky from a flat dome of points into something with depth, like turning the pages of a book and finally seeing the layers underneath. Kirshner and his colleagues were doing what astronomers had begun to do everywhere in the late 1970s and early 80s. They were measuring redshifts of as many galaxies as they could in particular patches of sky, hoping that when they were finished they would have a three-dimensional map of how galaxies are arranged in space. They expected the result to be reasonably uniform. The universe, on the largest scales, was supposed to be smooth. Galaxies were supposed to be more or less evenly scattered, like grains of sand strewn across a beach, with some dense places and some thin places. But no, enormous gaps. What they found instead was nothing. Or rather, they found a region of the sky in the direction of Boötes that, beyond a certain distance, simply seemed to have no galaxies in it at all. They measured the redshifts of every galaxy they could find in their target field, and they expected to see the redshift values spread out across a wide range, corresponding to galaxies at many different distances. Instead, they saw clusters of values bunching up at certain ranges, and then, in one specific range of redshifts, almost nothing. There was a quiet pause in the data, a gap, a long, smooth, eerie, empty stretch where there should have been galaxies. At first, no one quite knew what to make of it. When the team published their results in 1981, they wrote them up cautiously, as good astronomers do. They reported a 1,000,000 cubic megaparsec region with very few galaxies in it. They estimated its diameter at about 150 million light-years across, perhaps more. Even at that initial, tentative size, the result was startling. The standard model of cosmology, the picture of the universe as a smooth and gently lumpy place, had no easy room for an empty region that large. Voids were known. Astronomers had begun to suspect that the universe was full of underdense regions. But this one looked different. This one looked too big. In the years that followed, more redshift surveys were conducted. The total number of galaxies measured in nearby cosmic space went from a few thousand to tens of thousands, and eventually into the millions. The patch of emptiness in Boötes did not vanish. Instead, with more data, it expanded in size. Subsequent surveys traced the void out to a diameter of about 330 million light-years across, and confirmed that within this enormous bubble there were strikingly few galaxies. The number of galaxies inside the void grew, slowly, as bigger telescopes peered deeper, but it never grew quickly enough to fill the bubble. Today, after more than 4 decades of careful work, we believe the Boötes Void contains around 60 galaxies. That sounds like a lot of galaxies, until you remember that a region of similar size, anywhere else in the cosmic web, would contain perhaps 2,000. 60 instead of 2,000. A region in which roughly 97 out of every 100 galaxies that should have been there are simply, quietly not. We have, so far, found nothing comfortable to say about that fact. Imagine, for a moment, the moment of discovery itself. Picture a cool dome on a mountaintop, the air thin and dry, the stars so sharp they look like cuts. Inside the dome, a young man and his colleagues are watching numbers slide down a paper printout, or perhaps glow softly on the green and amber phosphor of an early computer screen. They have been at it for hours, measuring spectra, recording redshifts, plotting points. The work is monotonous in the way that meaningful work often is. And then, almost in passing, someone notices that one strip of the chart has gone quiet. The points are not appearing where they should. They look at each other. They check the data again. They check the calibration of the instrument, the alignment of the telescope, the integrity of the photographic plates. Everything is fine. They look back at the strip. It is still empty. There is a place in the sky, big enough to swallow 1,000 galaxies, that on the chart in front of them holds none. That is the moment we begin from tonight. A small group of astronomers in 1981, looking at their data and slowly understanding that the universe has a hole in it. It took most of a decade after the original announcement before the astronomical community had truly absorbed the result. The first paper, published in 1981, was titled, in the careful prose of scientific literature, "A Million Cubic Megaparsec Void in Boötes." The title itself was an understatement. It described, in the calm voice of a research note, something that nobody had ever seen before. The community was skeptical, in the gentle way that good scientists are skeptical of any new claim. Voids of that size did not fit easily into anyone's expectations. 1,000,000 cubic megaparsecs sounds, to a casual reader, like a strange engineering specification. But to a cosmologist, it was a quiet earthquake. It said, in measured language, that there was an enormous, unexpected silence in the structure of the universe. For years afterward, more measurements were taken. Different teams using different telescopes and different surveys looked at the same patch of sky. Some of them found a few extra galaxies inside the void. Others confirmed that the great bulk of the region remained empty. By the late 1980s, it was generally accepted that the void was real, and that it was very large. The original team had estimated it as roughly 150 million light-years across in their initial paper. Subsequent surveys nudged the figure upward, and the void grew slowly in the literature, expanding into something even more unusual. In 1995, an astronomer named Greg Aldering, together with his colleague Greg Bothan, published a more detailed survey of galaxies in and around the Boötes Void. They confirmed the basic shape of the void and described its inner population. They measured the magnitudes and the redshifts of the galaxies they could find. They mapped, as carefully as they could, the boundaries of the empty region. And it was Aldering who, in a public lecture, offered the famous quiet sentence we will return to later, the gentle remark that if our Milky Way were inside the Boötes Void, we would not have known about other galaxies until very recently. It is a sentence that has been repeated many times since then. It has the quality of the kind of fact that, once heard, you remember forever, even if you never plan to. The universe is so large and the void is so big that an entire cosmic neighborhood has had to learn about its surroundings in much greater isolation than we have. Of course, the original discovery was not, in itself, the most important consequence of those early redshift surveys. The Boötes Void was just one of many results that emerged from the patient work of charting nearby galaxies. The same projects that revealed the void also revealed walls and filaments and superclusters. They showed that the universe had structure on scales no one had quite expected. The void was, in some sense, the most dramatic feature on the map, but the map itself was the real revolution. Before those first redshift surveys, most descriptions of the universe assumed it was, on large scales, more or less smooth. There were galaxies, and there were clusters of galaxies, but beyond that, it was felt that the cosmos was more uniform than not. The new maps showed that the truth was much more interesting. The cosmos was textured. It had pattern. It had geography. And the discovery of the Boötes Void, in particular, was a dramatic visual demonstration that some parts of this geography were truly enormous and truly empty. In the decades since, the Boötes Void has acquired several other names. Some astronomers call it the Great Void, although there are now other voids known to be even larger. Some call it the Supervoid, although that term too has become more general. Among researchers, it is sometimes simply called the Boötes underdensity. To the public, it has become the most famous empty place in the cosmos, and that fame is well deserved. It was the first time humanity ever saw in detail that the universe was not just lumpy, but actually structured, with mountains and valleys, with crowded thoroughfares and silent, unpeopled prairies, with a kind of geography of presence and absence on the very largest scale we are able to look at. In the chapters of this story still to come, we will look at the void from many different angles. We will think about its sheer physical size, and we will try to feel the strange dimensions of it in our bones. We will think about the cosmic web, the structure that is supposed to fill the universe with galaxies, and we will think about why that web seems to have left this one place almost untouched. We will visit, in our imagination, the few galaxies that do live inside the void, and we will ask what it might be like to look up at the sky from a planet orbiting one of those galaxies. We will examine the theories that have been offered to explain how a hole this large could exist at all, and we will see how many of those theories sit quietly at the edge of what physics can currently say. And finally, near the end of this long, slow night, we will think about what it means for us that the universe has rooms in it as empty as this one. But none of that needs to happen quickly. None of it needs to happen all at once. Tonight, we are simply going to begin the way astronomers themselves began, with one quiet observation, one small piece of data that did not look right, one unexpected silence. There is a place in the sky, in the direction of the Herdsman, where the universe seems to have gone quiet. Sometime around 700 million light-years from where you are lying right now, the cosmic web that fills almost everywhere else begins to thin. The walls of galaxies fall away. The filaments unravel. The crowded clusters break apart. And then there is nothing. For 330 million light-years, in nearly every direction, almost nothing. A bubble of emptiness, suspended in the cosmos, slowly drifting along with the rest of the universe as it expands. You do not need to do anything with that information. You do not need to remember it tomorrow. You do not need to picture it perfectly. Tonight, all you have to do is hear it, like a story being told in another room. The universe has a hole in it. The hole has been there longer than the Earth has existed. It does not know we are looking at it. It does not know anything at all. And in this very moment, while you lie still and breathe, the light that left the inside edge of that void, hundreds of millions of years ago, is traveling through the dark space between galaxies, on a journey it will not finish in your lifetime. Most of that light will never reach our telescopes. Most of it will never be seen by any eye or any camera or any conscious being. It will simply travel and travel until at some point in a future too distant to imagine, it loses itself in the deep red shift of the cosmic background. We are going to follow some of that light for a little while, slowly, gently, together. Welcome to the Boötes Void. Part 2. The geometry of nothing settled deeper into your bed. Let your jaw soften. Let your hands rest where they are. Now we are going to stay with one number gently for a while. 330 million light-years. That is the diameter of the Boötes Void. From one inside edge to the inside edge directly across, it is 330 million light-years. This is the distance light travels in 330 million years. Light, the fastest thing in our universe, the speed limit of cause and effect, the steady envoy of every star. To cross the inside of this one void, even light needs 330 million years. To put a number like this into the body, we have to break it open very slowly. Begin with our planet. The Earth is a small rocky world, about 8,000 miles in diameter. Our nearest companion, the Moon, sits 240,000 miles away. Light takes a little over a second to make the trip. When you watch the Moon at night, you are seeing it as it was a moment ago by your own breath. That is the scale on which most of life is lived. Move outward. The Sun sits 93 million miles from Earth. Light from the Sun takes about 8 minutes and 20 seconds to reach us. The sunlight on your skin during the day was made some 8 minutes ago in the heart of the Sun, and traveled here through the cold of space to land on the back of your hand. Imagine that. The warmth you felt today was already an old story by the time it arrived. Outward again. The most distant planets in our solar system, Neptune and the dwarf world Pluto, are several light hours away from the Sun. Voyager 1, the farthest spacecraft humans have ever launched, is now about 23 light hours away. We followed Voyager once, on another night. We will not follow it again here. But take a moment to remember it, drifting through the dark, well past everything we know how to visit. Beyond Voyager, beyond the gravity of the Sun, lies the great cold of interstellar space. The nearest star to us is Proxima Centauri, just over 4 light-years away. That is, light traveling at 300,000 kilometers per second takes more than 4 years to bridge the gap. Our own galaxy, the Milky Way, is 100,000 light-years across. If you took your right hand and held it up in front of your face right now, with the palm facing you, the lines of your palm could be the spiral arms of the galaxy, and the entire history of human civilization, all of recorded culture and language, would be a single small flash in one tiny region of one of those lines. Now we begin to climb the ladder of distance more steeply. Beyond the Milky Way is the local group, a small cluster of galaxies that includes us, the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies. The local group is about 10 million light-years across. Already we have multiplied our scale by a factor of 100. The light that reaches us from Andromeda, the nearest large galaxy, was emitted around 2.5 million years ago, before any modern human had walked the Earth. Beyond the local group lies the Virgo Supercluster, a much larger arrangement of galaxies that contains thousands of individual galaxies, and is more than 100 million light-years across. Our local group is just one quiet suburb of this larger structure. And beyond the Virgo Supercluster lies a still larger one, called Laniakea, a Hawaiian word that means immeasurable heaven. Laniakea is about 500 million light-years across, a slow drifting current of galaxies that all share a common gravitational flow. We are part of this larger river, although we cannot feel it. And here is where we have to stop and acknowledge something. The Boötes Void is, on its own, more than half the diameter of the entire Laniakea Supercluster. Take a moment with that. The largest gravitational structure that contains us, the river of all the galaxies that we are tethered to, the immeasurable heaven we belong to, fits inside about 1.5 lengths of the Boötes Void. The void could swallow most of the structure that we use to define our own place in the cosmos, and still have room left over. The volume of the void, if we think of it as roughly spherical, is around 230,000 cubic megaparsecs. Astronomers use a unit of distance called the megaparsec, which is about 3.26 million light-years long. A cubic megaparsec is the volume of a cube 3.26 million light-years on each side. 230,000 of those make up the volume of the Boötes Void. If you were to count all the galaxies that should be inside such a volume, based on the average galaxy density of the universe, you would expect somewhere around 2,000. Instead, we have found, even with our most patient instruments, only 60 galaxies, in a volume that should hold 2,000. The vast bulk of the void is a slow, gentle, silent emptiness. It is, by any honest accounting, a hole in the universe. It is hard to picture this with the mind alone. So perhaps we should try a different approach. Imagine, for a moment, that we shrink everything down. Suppose we took the entire observable universe, 93 billion light-years across, and we shrank it to the size of the Earth. On that scale, our Milky Way galaxy would be about the size of a grain of sand. The local group would be a small cluster of grains, a tiny pinch. The Laniakea Supercluster would be roughly the size of a small city, and the Boötes Void would be a sphere about the size of a large town, carved out of nothing in the middle of a vast continent of glittering galactic dust. Almost nothing inside it. Just a single soft hush in the middle of all that crystalline structure. Or imagine, instead, that we kept the size of the universe the same and shrank the speed of light. Suppose light no longer moved at 300,000 kilometers a second, but at the speed of the fastest car you have ever ridden in, perhaps 150 kilometers per hour. At that speed, a beam of light would still take 330 million years to cross the void. The universe would shrink, in a sense, to a manageable size, but the void would remain just as time-consuming. It would still be the longest road most of us could imagine. A road that could be driven without any company at all, day after day, year after year, for hundreds of millions of years, and never come to anything. Of course, this is a kind of game. There is no way to truly shrink the void, and there is no way to actually drive across it. But sometimes the games we play with numbers are the only way our minds can begin to approach scales like this. We are creatures of meters and minutes. We were built, in the slow workings of evolution, to track the movement of small animals through small forests. We were not built to feel 330 million light-years. The fact that we can describe such a distance at all, in any language, is one of the quiet miracles of being human. It might also help to think about how the void appears in time as well as in space. The redshift of the Boötes Void corresponds to a distance of around 700 million light-years from us, give or take some amount depending on which precise edge we are talking about. That means that when we look at the inside of the void today, we are not seeing the void as it is now. We are seeing it as it was 700 million years ago. The light that reaches us from any galaxy or any structure in or near the void began its journey when life on Earth had just begun to develop into the first multicellular organisms. The first complex animals had not yet appeared. The continents were arranged into shapes no modern map would recognize. The light was already on its way before the first dinosaurs. It has been traveling for a very long time. By the time it reaches our telescopes, it carries with it a kind of fossil image of how the void looked in another era of the universe. In the time since then, the void has not stayed the same. Like everything else in the universe, it has expanded. The galaxies on its inside walls have drifted further apart. The handful of galaxies inside have moved through their long, slow trajectories. New stars have formed and died inside those galaxies. None of this is visible to us yet. We are watching, as always, an old story. There is something gentle about that. We never see the universe as it is. We see the universe as it was. And the deeper we look, the older the story becomes. Looking at the Boötes Void is, in a way, like reading a letter mailed long ago. The hand that wrote it is no longer where it was when it wrote. The room may have changed. The world the writer described may no longer exist in the same form. But the letter is here. The letter is real. It carries the truth of one moment in time, and it lays that truth gently in front of us, like a still leaf pressed in a book. If you were able to sit, somehow, just inside the boundary of the Boötes Void, 350 million light-years from Earth, looking back toward us, you would see Earth as it was 350 million years ago. You would see, if your eyes were impossibly sensitive, the beginnings of forests, the first amphibians crawling out of warm, shallow seas, an Earth still so young that mammals had not yet appeared. You would not see us. We are too small, too recent, and too quiet to have left a signal that would have reached you yet. This is a lovely thought. The void does not know about us. None of the galaxies inside the void know about us. And the Earth, in the way of all things, sends only the light it has had, never the light it will have. Whatever signature the human species is making on this small blue world will take a very long time to arrive at the boundaries of the void, and longer still to leak inward to its lonely interior. By the time it does, we may not be the species we are now. So we sit here, in our beds and on our pillows, in this brief moment of life, and we look outward at a whole so old that it has barely heard of us. There is a peace in that. We will get to the cosmic web in the next part of our journey, and to the strange way the universe is built, like a kind of foam of galaxies wrapped around enormous bubbles of empty space. And we will ask, calmly and patiently, why one of those bubbles is so much larger than it has any right to be. But before we move on, take a few breaths to let the size of the void settle into your body. Let us linger for a moment with the experience of distance in some other smaller forms first, so that we can carry it gently into the larger one. When you make a phone call across the world, your voice travels along an undersea cable, sometimes for tens of thousands of kilometers, in a fraction of a second. That entire planetary journey around the curve of the Earth takes less than the time it takes you to blink. To light, the entire surface of our planet is small. The Earth is small. The Moon, that beautiful pale companion, is only a little over 1 second away by light. It is, in cosmic terms, almost in our lap. The Sun is 8 light minutes away. Your morning coffee, if you drink it slowly, is the same length of time as the journey of sunlight from the sun to your kitchen window. Already this is a kind of long road, and yet it is invisible to your senses. You do not notice that the sunlight on the table is 8 minutes old. It is, for you, simply morning. Beyond the sun, the entire solar system fits inside about 13 light hours, more or less, depending on where the outermost dwarf planets happen to be in their long, slow orbits. A photon, leaving the Sun, can cross the orbit of Pluto in under half an Earth day. The whole architecture of planets and moons and asteroids that fills our local sky is, by light's standards, a single afternoon's drive. The nearest star, Proxima Centauri, is more than 4 light-years away. Already we have moved into a different category of distance. Light, leaving Proxima now, will not arrive at our telescopes until well into our future. If, somewhere on a planet around Proxima, a brief, unexplained flash of light occurred this evening, we would not see it on Earth until the year 2030 or beyond. The fastest information in our universe, news of an event, takes more than 4 years just to leap across that one tiny gap to our nearest neighbor star. The Milky Way galaxy, our home, is 100,000 light-years across. To cross the diameter of our galaxy at the speed of light requires the entire span of recorded human civilization several times over. The light leaving the far edge of the galaxy now will not reach the opposite edge until civilizations on Earth that no one has yet imagined have come and gone. And the Milky Way is one of 2 large galaxies in the local group, which is roughly 10 million light-years across. To cross the local group at the speed of light requires more time than has elapsed since the very first hominids first walked on 2 legs. We are, evolutionarily speaking, a recent species. Our entire lineage, from the first upright primates to today, fits within the time it would take light to skip from one corner of our small cluster of galaxies to the high other. Now multiply by another factor of about 33. That is the diameter of the Boötes Void, 330 million light-years. It is more than 30 times the diameter of the local group. It is more than half the diameter of the Laniakea Supercluster. It is, by any measure that human language has yet been able to invent, large beyond easy comprehension. If you wanted to fit Milky Way galaxies side by side across the diameter of the Boötes Void, you would need 3,300 of them, lined up edge to edge. 3,300 islands of stars, suspended in a row, would just barely span the empty interior. And in the actual void, even those 3,300 placeholders are not there. There is, inside the void, almost nothing. It might also help to think in terms of time on a planetary scale. 330 million years ago, on Earth, the continents had not yet drifted into their familiar shapes. Pangaea was still in its long process of forming. The first reptiles were just beginning to develop in damp, fern-filled forests. The dinosaurs were tens of millions of years away from their first appearance. The shape of life on Earth in the era that produced the light we now see from the void is almost unrecognizable to us. In other words, the time it takes light to cross the inside of the Boötes Void is similar to, or even longer than, the entire history of complex animals on our planet. The light traveling across that emptiness right now, beginning at one inside wall and ending at the other, will not finish its journey until many epochs of Earth's biology have come and gone. The slow journey of one beam of light across this one void can outlast the entire reign of any single class of large animals on our world. That is what 330 million light-years means. 330 million light-years across. Light leaves the inside wall of the void, rolling outward through nothing, and travels for hundreds of thousands of generations of human time before it reaches the inside wall on the other side. Whole civilizations could rise and fall along the way, on planets that do not exist, in sunlight that is not there. The void simply sits, and the universe around it expands, and every galaxy on its outside is a little farther from every other galaxy on the next outside, and the void grows with the rest of the cosmos, slowly, quietly, very far from us. You do not have to hold any of this. You do not have to keep it. You can let it pass through you, the way you might let a soft breeze pass through an open window in summer. The void has been there for a very long time. The void will be there long after this night. It will be there when you wake up, slightly more rested, somewhere on the morning side of the world. And it will be there tomorrow night, and the night after, when you decide to come back and learn a little more about it. For now, it is enough simply to know that the universe is wider and stranger, and more full of nothing than we ever expected it to be. Part 3. The Cosmic Web and the Bubbles. It forgot. You may already be growing drowsy. That is good. We are going to keep our voice low and our pace gentle. To understand why the Boötes Void is strange, we have to understand the rest of the universe. We have to understand the structure into which the void was born. Because the universe is not, as people once thought, an empty room sprinkled evenly with galaxies. It is not a smooth, velvet sky punctuated by pinpricks of light. It is something far more interesting than that. It is a structure. It has shape. It has pattern. It has rooms and corridors and hallways and walls. And the Boötes Void is one room in this structure that is enormously, astonishingly larger than any of its neighbors. The shape that the universe takes on its largest scales is called the cosmic web. Imagine, if you can, the inside of a soap foam. Take a glass of warm water with a little dish soap in it and stir gently until you raise a froth of bubbles. Look closely at the surface of the foam. You will see thousands of tiny bubbles packed against each other, with thin films of soap stretched across their boundaries. Where two bubbles meet, the films press together into a flat wall. Where three bubbles meet, the walls converge into a long, thin filament. Where four or more bubbles meet, the filaments converge into a small, bright knot. The interiors of the bubbles are mostly air. The structure of the foam is held in the soap films, the walls, the filaments, the knots. Almost all of the soap is in the boundaries between bubbles, and almost none of the soap is in the bubbles themselves. The universe, on its largest scales, looks like this. Galaxies cluster in walls, and the walls press together into long, thin filaments, and the filaments converge into massive knots that we call superclusters. The interiors of the cosmic bubbles, the regions surrounded on all sides by walls and filaments, are mostly empty. We call those interiors voids. This is not metaphor. This is what we actually see when we make three-dimensional maps of where galaxies are in the universe. In the late 1970s and early 1980s, the first redshift surveys, including the same line of work that found the Boötes Void, began to reveal the structure clearly. In the late 1980s, a team led by Margaret Geller and John Huchra at the Harvard-Smithsonian Center for Astrophysics produced a now famous map of the local universe. They had measured the redshifts of around 15,000 galaxies in a wedge of sky. And when they plotted the galaxies in 3 dimensions, the result took everyone's breath away. The galaxies did not fill space evenly. They were arranged in great, long, thin sheets and curls, with vast, empty regions between them. One of the structures they discovered was so long they called it the Great Wall. It stretched across hundreds of millions of light years of the local universe. Inside the Great Wall, galaxies were packed together. On either side of it, stretching away into the dark, were enormous empty pockets. The universe was foam. The galaxies were the soap films. The great voids were the trapped breaths of nothing in the middle. Since then, much larger surveys have confirmed and extended this picture. The Sloan Digital Sky Survey, beginning in the year 2000, has measured the positions and redshifts of more than 1 million galaxies. The 2-degree field galaxy redshift survey, the 6-degree field survey, the 2-mass redshift survey, the galaxy and mass assembly survey, and many others have built up a stunningly detailed picture of how matter in the universe is distributed. They all show the same thing on different scales: walls, filaments, knots, voids, the cosmic web. How did this structure come to be? How did matter in the early universe settle into such an elaborate scaffolding? The answer takes us back to the very young universe, only a few 100,000 years after the Big Bang. At that time, the entire cosmos was filled with a hot, dense plasma of protons, electrons, photons, and a thin garnish of helium nuclei. There were no stars yet. There were no galaxies. There was, in the simplest description, just a thin uniform fog of hot stuff, glowing softly red-orange across the entire sky. But this fog was not perfectly uniform. There were tiny ripples in it. Tiny, almost imperceptible fluctuations in density. Some places were a little denser. Some places were a little less dense. The differences were exquisitely small. We are talking about variations of 1 part in 100,000. If you imagine a still pond that has been disturbed by a single dropped pin, the ripples that follow are larger than the variations in the early universe. And yet those tiny variations were enough to shape everything that came after. The slightly denser places had a little more gravity. They pulled in surrounding matter. Over millions and then billions of years, the densest regions grew denser. The thinnest regions grew thinner. Matter flowed from low-density places to high-density places. Galaxies formed in the densest knots. Filaments and walls of galaxies formed where matter streamed inward along certain preferred directions. The thinnest regions, where matter had been a little below average to begin with, slowly emptied themselves out as their matter drained into the surrounding walls. Those were the voids, born from being slightly less dense and growing emptier and emptier as the universe aged. The cosmic web, in this picture, is a story of gravity acting on a faint pattern of imperfections. The seeds were laid down in the very first fractions of a second after the Big Bang, during a period called inflation, when the entire universe expanded enormously in a brief moment, stretching tiny quantum fluctuations into the vast pattern of density variations that gravity later carved into walls and filaments and voids. The universe we see today, with its glittering galaxies arranged into a crystalline foam, is a very large, very slow, very patient elaboration of those first quantum whispers. There is something deeply tender about that. The structure of all the galaxies we will ever see, the long curving filaments of light, the dense, brilliant superclusters, the quiet, empty voids, all of it was once a faint trembling in the heat of the early universe. A subtle inhomogeneity in a sea of hot fog. Gravity took that trembling and, over 13 billion years, sculpted it into the pattern of everything. And here is where the Boötes Void comes back into the picture. If we ask a computer to simulate the growth of structure in the universe from a small spectrum of initial fluctuations, with the right amount of dark matter, the right amount of dark energy, and the right physical laws, the computer will obediently produce a cosmic web. That web will have walls, filaments, knots, and voids. The voids will be of many different sizes. Most of them will be small. Some will be larger. The largest, in a typical simulated universe consistent with what we observe, will be perhaps 100 or 200 million light-years across. They will not be everywhere. They will be relatively rare, but they will exist. The Boötes Void is bigger than that. 330 million light-years across is bigger than what most simulations of the Standard Model predict for typical voids. Voids that large are not impossible in the standard cosmological picture. They are simply rare. The Boötes Void does not break the standard model, but it sits at the edge of what the standard model expects, like a guest at the far edge of a long banquet table, far enough out that you have to crane your neck to see them at all. It is one of several large voids that have made cosmologists slightly uncomfortable. In 2007, astronomers using the Wilkinson Microwave Anisotropy Probe and a survey called the NRAOVLA Sky Survey found a large region in the constellation Eridanus in the southern sky, sometimes called the Eridanus Supervoid or the Cosmic Microwave Background Cold Spot, where the cosmic microwave background was unusually cold. Some early estimates put a possible underlying void there at perhaps 1 billion light-years across, although later observations have softened that estimate considerably. There are other very large voids and very large structures. There is a string of quasars known as the Huge Large Quasar Group, which is more than 4 billion light-years long. There is something even larger called the Hercules Corona Borealis Great Wall, which, depending on how you count it, may stretch across 10 billion light-years. These are at the edge of the universe's large-scale structure, as we currently understand it. For the most part, the Boötes Void fits in this same family of large but not impossible objects. It is not the largest empty region in the universe. It is, though, one of the most famous and one of the most studied. It was the first really big void to be found, and it remains a kind of touchstone for studies of large-scale emptiness. There is a useful word that astronomers sometimes use to describe regions like the Boötes Void. They call them underdensities. The word is gentle and modest. It means simply a region with less density than average. A piece of the universe that is, for whatever reason, less full than the rest. The Boötes Void is a strong underdensity, an unusually long stretch of below-average density. Why did this particular bubble grow so large? There are several possibilities. One is that it grew from a particularly extreme early underdensity, an unusually thin spot in the original fluctuations. In the standard model, there is a probability distribution of how thin or how thick early density fluctuations can be. Most fluctuations are close to average. A few are extreme. The Boötes Void may have begun as an unusually deep negative ripple in the very young universe, a place that started out a little emptier than its neighbors, and then grew steadily emptier as gravity drained matter outward into the surrounding walls. Another possibility is that the Boötes Void is actually a merger of several smaller voids. Smaller bubbles, growing next to each other, could have eaten through the walls between them and connected into one larger bubble. Some surveys have suggested exactly this for the Boötes region. There is a faint suggestion of internal structure inside the void, a few thin walls of galaxies that hint at the seam line where smaller voids may have grown into one another. In this picture, the Boötes Void is not so much a single primordial gap as it is a confederation of gaps that joined hands. A third possibility, more speculative, is that the Boötes Void may be a clue that we do not yet fully understand the recipe of cosmic structure formation. There may be additional physics, beyond the standard model, that nudges the early universe to occasionally produce extra-large voids. Some theorists have entertained ideas like primordial cosmic strings, hypothetical thread like defects in the early universe that could have left imprints on the distribution of matter. Others have suggested early dark energy, a brief period of accelerated expansion in the cosmos's first billion years, that could have stretched some underdensities out beyond normal expectations. We will return to these possibilities later. For now, what matters is that the Boötes Void is part of the larger story of the cosmic web. It is part of the foam. Its existence is consistent, in broad strokes, with the way we believe the universe formed. It is just unusually big. It is the kind of bubble that, in the soap foam of all that exists, makes you stop stirring for a moment and look more carefully at your glass. Take a few slow breaths. Let your hands grow heavier. Let any thoughts of tomorrow drift gently away, the way late evening clouds drift away after a long sunset. The cosmos is foam. It is filled, almost everywhere, with thin, glittering walls of galaxies. Between those walls, there are bubbles of empty space. Most of the bubbles are smaller. One of them is unusually large. One of them sits in the direction of the Herdsman, 700 million light-years from where you are lying right now. A breath of nothing, 330 million light-years wide, suspended in the dark. It might be useful to pause for a moment and think more concretely about what cosmic structure looks like elsewhere in the sky, so that we can feel the contrast between Boötes and the more familiar parts of our cosmic neighborhood. In the constellation Coma Berenices, for example, lies the Coma Cluster, a dense knot of more than 1,000 galaxies bound together by gravity. The Coma Cluster is part of a larger structure called the Coma Supercluster, and beyond that, it is connected by long filaments of galaxies to other superclusters in adjacent regions of the sky. If you were to trace, on a three-dimensional map, the way galaxies arrange themselves around the Coma Cluster, you would see a busy network. Long, thin chains of galaxies feed into the cluster like rivers feeding into a lake. Smaller clusters cling to the outer reaches. The local cosmic web there is rich, woven, intricate. There is, in that direction, a sense of fullness. In the direction of the constellation Hydra lies a much larger structure called the Great Attractor, a region of unusual gravitational concentration that pulls our entire local group of galaxies through space at hundreds of kilometers per second. The space around the Great Attractor is similarly full of galaxies, walls, and clusters. We have explored the Great Attractor on another night. It is, in many ways, the opposite of a void. It is a dense concentration so massive that it shapes the motion of everything around it for hundreds of millions of light-years. In the constellations of Pisces and Cetus, far below the celestial equator, lies the Pisces-Cetus Supercluster complex, an even larger arrangement that some astronomers describe as a kind of cosmic ribbon, stretching across more than 1 billion light-years of space. It is one of the largest known concentrations of galaxies in the nearby universe. Each of these structures, the Coma Supercluster, the Great Attractor, the Pisces-Cetus complex, the Sloan Great Wall, is a place where matter has crowded together. Each of them, in its own way, is a positive feature on the cosmic map. They are bright places. They are full places. The Boötes Void is the opposite. It is a negative feature on the cosmic map. It is a place where matter has thinned out almost to nothing. It is a kind of cosmic anti-structure, defined not by what is there, but by what is not. And here is the gentle counterpoint to remember. Both kinds of features, the dense and the empty, are part of the same cosmic web. They were shaped by the same processes. The same gravity that pulled matter into the Coma cluster also drained matter out of the Boötes Void. The same early density fluctuations that produced the Sloan Great Wall also produced the gentle bubble in Boötes. The walls and the empty rooms are part of one structure, like the soap films and the air bubbles of a single foam. In the language of cosmologists, the universe is described as having undergone a process of structure formation, in which slight overdensities became great walls and slight underdensities became great voids. Both directions of structure are real. Both are necessary. A universe of only walls would be impossible. A universe of only voids would be impossible. The cosmos has both, in proportions set by the laws of gravity acting on the early density fluctuations of the Big Bang. The Boötes Void is one of the largest known voids. There are now several other voids of comparable size that have been discovered, including the Herdsman Supervoid, the local hole, and the KBC void in which our own galaxy may sit, although that last identification is still under active investigation. Together, these large voids form a kind of family of underdensities scattered across the observable universe. Each one is a slightly different example of the same general phenomenon. It is allowed by the laws of the universe. It is rare, but it is not forbidden. It is unusual, but not impossible. It is not a flaw in our picture of the cosmos. It is simply the most spectacular example we have so far found of how empty things can get when given enough room and enough time. We will keep walking through this story together. We will, in the next part, step inside the void. We will not actually go anywhere, of course. We will simply imagine. We will think about the few galaxies inside the void, and we will picture, in the gentlest possible way, what it might be like to live in one of them, what the sky might look like, what it might feel like to be the only galaxy a human astronomer in such a place could see. Until then, breathe slowly. Picture the foam of the universe. Picture the long, thin walls of galaxies glowing faintly in the dark. Picture the great bubbles of nothing between them. Picture, as gently as you can, the unusually large bubble in the direction of Boötes, drifting along with the cosmic flow, as quietly as a drop of water sliding down a window pane. You do not have to do anything else. You do not have to remember anything. The story will be here when you next reach for it. Part 4. The Ghosts That Live Inside. We are going to try, very softly, to step inside the void. Of course, we cannot really go there. Even if we could travel at the speed of light, we would never reach it. 350 million years is longer than the entire history of mammals. A spaceship leaving Earth tonight at the speed of light would still be on its way through the outer wall of the void when our species had long since vanished from the planet. So, the journey we are about to take is purely imagined, but sometimes imagination is the only telescope we have. Imagine, then, that you are no longer in your bed. Imagine that you are floating, weightless, somewhere inside the Boötes Void. You are not on a planet because there are no planets that we know about that close to the center of the void. You are just a quiet observer, suspended in the dark. Look around. In every direction there is darkness. The deep, velvety black of intergalactic space with no nearby stars, no nearby gas clouds, no nearby anything. If you turn very slowly, you will see almost nothing at first. The space around you seems to contain nothing at all. The air, of course, would not exist, but in our imagined version of this scene we do not have to worry about that. We are simply looking. Now, extend your gaze further. Far in the distance, you can begin to see a few faint smudges of light. Tiny galaxies scattered through the inside of the void. Some of them are tens of millions of light years from where you are floating. Even on the largest scales, they are sparse. In a region this size, somewhere in the middle of the cosmic web, you would expect to see 2,000 galaxies arranged in walls and filaments and small clusters around you. Here, you can count perhaps a few dozen at most. They are tiny. They are quiet. They are scattered with great distance between them, like solitary travelers in a wide, wide desert. This is what an astronomer named Greg Aldering once described in one of the most famous quiet sentences in modern cosmology. He pointed out that if our Milky Way galaxy were located at the center of the Boötes Void, we would not have known there were other galaxies in the universe until the 1960s. Until then, our most powerful telescopes simply would not have been able to detect any of the few faint companions that share our void. We would have looked out at our own quiet pinwheel of stars, and beyond them we would have seen nothing. Imagine, very gently, that this is the case. Imagine you are an astronomer on a planet circling a star in a galaxy floating somewhere inside the Boötes Void. The galaxy is not unusual in any way. It is a spiral galaxy, perhaps, or a softly elliptical one. Its stars cluster around its center, and its arms, if it has them, sweep outward into a nighttime sky that, from your planet, looks like a long, bright band of milk across the dark. You and your civilization have invented telescopes. You have looked carefully at the stars. You have learned that some of those stars are very far away. You have built bigger and bigger instruments. You have aimed them at the sky. What do you see? You see your own galaxy, of course. You see the constellations, just as we see ours, formed by patterns of stars at distances of dozens or hundreds or thousands of light years. You see the central bulge of your galaxy in the heart of your night sky. You see the dust lanes of its spiral arms, glowing faintly against the dark. You see, here and there, bright nebulae lit up by hot young stars. You see the slow circling of star clusters around the center of your home. But you do not see other galaxies. When your astronomers point their telescopes carefully at the empty regions between the stars, they do not see the soft glow of distant galaxies that fills our own dark sky. They see only black. They see, perhaps, very faint smudges if their instruments are extremely sensitive. But these smudges are sparse. They are far. Most regions of your sky look completely featureless beyond the stars of your own galaxy. There is no Andromeda in your sky. There is no Triangulum. There is no nearby Magellanic Cloud, unless one of your few neighbor galaxies happens to be a dwarf companion of your own. And even then, it is small and quiet. Your great walls and filaments of galaxies, the structures that tell us in our universe that we are part of something larger, are far enough away that they do not register easily in your telescopes. Your astronomers, looking at the sky, would conclude that your galaxy is alone. Or rather, they would conclude that your galaxy is the universe, just as we did in the first decades of the 20th century. Just as Edwin Hubble had to slowly demonstrate, again and again, before it was finally accepted that the soft blur of light we now call the Andromeda Galaxy was actually another spiral system, another universe of stars, far, far beyond our own. Hubble's measurements relied on being able to see individual variable stars in Andromeda. Inside the Boötes Void, you would not have anything that close. Your nearest galactic neighbor might be 20 or 30 million light-years away. You could not see individual stars in it with any telescope you might reasonably build. You would, at best, see a small, fuzzy dot. Eventually, perhaps, your astronomers might detect that fuzzy dot, and a few more, and after a long time they might start to wonder what these distant smudges were. But it would take much longer than it took us. Inside the Boötes Void, the discovery that the universe was made of galaxies, plural, would arrive slowly. It might take several extra centuries of telescope improvement. It might require the patience to detect smudges so faint that they barely register against the blackness of the sky. And throughout that long delay, The inhabitants of the void would have grown up believing in a much smaller universe. There is a kind of soft sadness in this thought. Imagine all the philosophy that might be written in such a place. Imagine the religions, the cosmologies, the songs. Imagine the way the children would look at the sky and assume that what they saw was all there was. Imagine the stars in their constellations being treated as the sum of creation. Imagine the slow, eventual realization that there was something else out there, after all, something faint, something old, something far, something that suggested that their galaxy was not alone, and never had been. That realization, when it came, would change everything for them. And here is the gentle reverse of that thought. We, in our own galaxy, did not have to wait so long. The universe arranged itself in such a way that we could see, with our naked eye, that nearby smudge that turned out to be the Andromeda Galaxy. Our place in the cosmic web is rich with neighbors. We have many galaxies nearby. We have entire walls and filaments and clusters within easy reach of our instruments. Our own discoveries about the size of the universe were made possible, in part, by the company we keep. For our imagined neighbors inside the Boötes Void, that company is not there. They live in a region of cosmic loneliness so wide that the sky itself keeps it secret. If you are listening tonight from a place where you sometimes feel alone, it might be worth pausing on this. We, in our galaxy, in our local group, in our part of the cosmic web, are not alone. We have neighbors. We have a wide and crowded patch of the universe within reach of even our oldest telescopes. The fact that we are surrounded by other galaxies is, in a quiet way, a piece of cosmic luck. It is the gentle company of the universe that helped us learn what we are. Inside the Boötes Void, that company is much, much sparser. The galaxies that live there are real. Some of them are well studied. They are not entirely without companions, but they live in a region so thinned out that the rest of the universe is, from their perspective, much more distant than it is from ours. What do those galaxies look like? Most of them are ordinary in their basic structure. Spirals, ellipticals, some irregulars. They have stars, gas, dust, and dark matter halos, just as galaxies in dense parts of the universe do. There are some interesting differences, though. Studies of galaxies inside large voids, including the Boötes Void, suggest that void galaxies tend to be a little smaller, a little bluer, and a little gas-richer than their counterparts in dense environments. The reason, in part, is that void galaxies have not been involved in as many gravitational interactions and mergers with their neighbors. In dense regions, galaxies often sweep past each other, sometimes colliding, sometimes losing or gaining gas, sometimes merging into larger systems. Inside a void, those interactions are rare. A void galaxy can drift, more or less undisturbed, through the long ages of the universe. It keeps its gas. It continues to form stars at a steady, gentle pace. It holds on to a kind of youthful look, even after billions of years. In a sense, void galaxies are slow. They are not slow in motion, but slow in change. They are less hurried. They have not been pushed and pulled by close encounters. They have not been forced to merge with louder, more aggressive neighbors. They are, by a gentle accident of their location, the introverts of the cosmic web. Within the Boötes Void, we have identified a few small structures even inside the bubble. Some of the void galaxies appear to be arranged along thin filaments inside the larger void, as if the inside of the bubble is itself faintly subdivided into still smaller bubbles. There are, in other words, layers of voids within voids. The Boötes Void is the largest and most striking of these, but it contains within it smaller substructures, like a faint geometric drawing barely visible on a piece of pale paper. Spend a moment, if you wish, with one of these galaxies. Imagine a spiral galaxy somewhere near the center of the Boötes Void. Its stars are billions of years old. It is forming new stars in its arms, slowly, peacefully, without any major collisions interrupting its work. It has small dwarf companions, perhaps 2 or 3, faint enough that they look from a great distance like tiny blurs around a pale wheel. The galaxy turns gracefully. Its arms wind slowly around the center. Light from new young stars in those arms shines outward into the surrounding emptiness, much of it never to be received by anyone. The galaxy is, in its own quiet way, sending out signals to a universe that does not have enough listeners nearby to hear most of them. This is the inside of the void. A few quiet galaxies, each one doing its own slow work of being a galaxy, in a region of space so empty that most of their starlight will simply travel and travel until it tires into the deep red glow of the cosmic background. It is easy to think of the void as a kind of cosmic loneliness, and in some sense it is, but it is also, in its own way, a place of peace. There are no violent collisions. There are no nearby supernova storms washing in from neighboring clusters. There are no quasar blasts from a nearby active galactic nucleus. The galaxies inside the void exist in a quietness that, on a long enough scale, is almost impossible to find anywhere else in the universe. If you wanted to live somewhere safe, statistically speaking, the inside of a large void might be one of the most peaceful corners of the cosmos. There would be very little traffic, almost no near misses. A clear sky for billions of years, a long, slow turning of the home galaxy, a long, slow falling apart of distant other galaxies as they receded into the red-shifted dark. So, when we say the void is empty, we are saying something true, but we are not saying it is dead. The galaxies that do live there are alive in the way galaxies are alive. They have stars being born. They have planets. They may, for all we know, have civilizations. Civilizations, perhaps, who look up at their skies and see almost nothing but their own home, and whose entire history of cosmology might be the slow, patient story of figuring out that they were not, in fact, the entire universe. Take a moment with that. The universe has, perhaps, civilizations as old as ours, or older, who never had the soft luxury of seeing nearby galaxies in their early astronomies. They had to work harder. They had to look longer. They had to wait through more centuries of darkness before their telescopes were sensitive enough to reveal that there was anything at all out beyond their own quiet wheel of stars. And now, in their version of our present, they would know what we know. They would know that there are other galaxies. They would know that they live inside a great empty bubble that the rest of the cosmos has built around them. They would know, perhaps, of us in our crowded part of the cosmic web, and they might marvel at the difference. There is a special kind of kinship that comes from sharing a problem, even if you never meet. Imagine 2 astronomers, separated by hundreds of millions of light years, both of whom have spent their lives trying to understand the structure of the cosmos. The astronomer in our part of the universe has had things easy, in a sense. She has had Andromeda visible to the naked eye. She has had whole walls of galaxies within reach of modest telescopes. She has had a dense cosmic neighborhood to study. The astronomer in the void has not had any of those things. He has had to invent every clever technique by hand. He has had to build telescopes more sensitive than ours simply to see what is there. He has had to imagine, carefully, the structure of a universe he could not directly see. He has had to take the small clues offered by his sky and stretch them with great care into a picture of something far larger than his sky suggested. Both of them, in the end, have arrived at similar truths. Both of them know that the universe is vast and full of galaxies and shaped like a foam. Both of them know that gravity is the architect, and that dark matter and dark energy play the leading roles. Both of them know about the cosmic microwave background. Both of them have noticed that something is unusual about the size of the empty bubble in which the void astronomer lives. They will never speak. They will never write to each other. They will never even know each other's names. But somewhere, in the very abstract space of cosmic understanding, they meet. They share a discovery. They share a way of looking at the cosmos. They are, in the only sense that matters across such distances, friends. We are kind of cousins, separated by a wall of nothing. That is one of the loveliest images this story leaves us. Not a wall of stone or steel, but a wall of nothing. A wall of distance and emptiness. A wall whose only material is the absence of material. And on either side of that wall, small wheels of stars turning patiently in the dark, each one with a few astronomers looking outward into a sky that, at long last, has begun to reveal itself. We will, in the next part of our journey, look at how scientists have tried to explain the void. We will look at the theories, both calm and bold, that have been offered. We will see how each one fits with what we know, and how each one leaves a little room for further questions. Until then, breathe softly. Allow the quiet of the void to settle into your bedroom. Picture a soft bubble, 330 million light-years across, drifting slowly along with the rest of the universe. Inside, a few dozen patient galaxies, doing their own work in the long darkness. You are welcome here in this picture. There is room, there is time, there is no rush, and there is no worry. The void is older than anything in your day, and it does not care about any of it. Your worries are too small for it. Your work is too brief. Your tomorrow is too soon. Whatever happens to you in the next 24 hours, the void will not have noticed. It will simply continue, as it has continued for so long, drifting along the slow currents of the cosmos, holding its small, quiet galaxies like a few candles in a very large, dark cathedral. Before we move on, let us spend a few more moments inside this imagined view, because the gentleness of it deserves time. You are still floating in the imagined center of the Boötes Void. The galaxies around you are very far away. Most of your sky is dark. There are no nearby stars to dazzle you. There is no warm orange glow of a nearby spiral. There is only the thin and patient distribution of distant lights, scattered like quiet candles in a great cathedral. Picture, more specifically, a single galaxy in the void. Picture a spiral galaxy somewhat smaller than our own Milky Way. It has, perhaps, 50 billion stars, where ours has several hundred billion. Its disk is broad, but a little less massive. Its arms are clean and well-defined, with younger stars lighting up the outer reaches. Its bulge is modest. Its halo of older stars is faint. It is, in essence, a calm spiral, drifting through the empty interior of the void. This galaxy has, like ours, dust lanes and emission nebulae. It has young stars wreathing its arms in soft, pink hydrogen alpha glow, and old yellow stars filling its central regions. It has stellar nurseries, where new stars are still being born, even today. It has cooling pulsars and silent neutron stars. It has black holes at its core. It has supernova remnants from stars that exploded long ago. Around this galaxy, in our imagined picture, orbits a small companion, a dwarf galaxy of perhaps a few 100 million stars. There may be one or two other dwarf companions. Together, this small system is the Void Galaxy's local family, much like our own local group, only smaller. Much smaller. There are no large neighbors. There is no bright spiral the size of Andromeda hanging in the sky. There is just the home galaxy and its little entourage of dwarfs, and otherwise, in every direction, very far away, only the few faint other galaxies of the void. Inside this home galaxy, on a planet around an ordinary star, perhaps there are creatures looking up. Perhaps they have eyes much like ours. Perhaps they have astronomy and philosophy and dreams. Perhaps they have evenings and beds and quiet voices, and they too like to listen to stories about the universe before they fall asleep. Their stories, of course, would be different from ours. Their cosmos, as they know it, is largely the inside of a great empty bubble. Their understanding of what lies beyond is hard-won, slow-built, and far from complete. But it is real. It is true. It is theirs. We do not know if such beings exist. We may never know. But the universe is so large, and the number of stars so vast, that even one or two galaxies inside the Boötes Void could host an enormous number of planets. Some of those planets must be habitable. Some habitable planets presumably develop life. Some life eventually develops minds. The numbers are very small, but the universe is very wide. Somewhere, at this very moment, there may be a quiet creature on a quiet planet inside the Boötes Void, looking up at a sky that, from their perspective, is as natural and unremarkable as ours is to us. That is one of the soft kindnesses of cosmology. It does not tell us that we are special. It does not tell us that we are alone. It simply tells us that we are one warm point in a long, slow, gentle pattern of warm points, scattered through the foam of the cosmos. Sleep, if sleep is near. The void will keep its place. Part 5. Theories of the Emptiness. There comes a moment in any honest scientific conversation when the conversation has to admit that it does not yet have all the answers. We have arrived at that moment now. The Boötes Void is one of the most studied empty regions in the universe, and yet there are still good, real, open questions about exactly how it came to be the size it is. Tonight, in this calm part of our story, we are going to walk through several of the explanations that have been offered, and we are going to do so without rushing, and without pretending that any one of them has been fully proven. You may, if you like, imagine each explanation as a small lantern lit in turn at the edge of a long, quiet field. We will walk past each lantern slowly, look at the light it casts, and then move on to the next. The first lantern, and the simplest, is the explanation that the Boötes Void is just an unusually deep early underdensity that grew normally. In the standard model of cosmology, which we sometimes call lambda CDM, the early universe was nearly uniform but had tiny ripples in its density. These ripples followed a kind of bell-shaped probability distribution. Most regions were close to average. A few were a bit denser. A few were a bit thinner. Over the long ages, the slightly denser regions became the great walls and clusters of galaxies, while the slightly thinner regions became the voids. Within this picture, there is room for occasional outliers. Now and then, by chance, a region of the early universe might have started off significantly thinner than its neighbors. Such a region, given billions of years of gravitational evolution, would empty out faster and to a greater extent than ordinary thin regions. The result would be an unusually large, unusually empty void. Detailed simulations of large volumes of the universe, with parameters consistent with what we see in the cosmic microwave background and in the distribution of galaxies, sometimes produce voids the size of the Boötes Void. Such voids are rare. They might appear once or twice in a volume comparable to our entire observable universe. So the existence of one Boötes Void is not, on its own, a serious surprise within the standard model. It is rare, but rare events happen. This is the calm answer, the boring answer, the one that probably most cosmologists, if pressed, would lean toward. The Boötes Void is rare but allowed. Lambda CDM is fine. The universe is permitted to have unusual holes, as long as they are not too unusual and as long as they are not too many. But there are other lanterns to look at. The second lantern is the merger lantern. Some studies of the Boötes Void have suggested that it may not be a single primordial void at all. It may, instead, be a combination of several smaller voids that grew next to each other and eventually merged. The mechanism is straightforward. Two voids growing in adjacent regions would eat outward into the surrounding walls of galaxies. As they grew, the wall between them would grow thinner. Eventually, that wall could break apart, and the two voids would fuse into one larger void. If 3 or 4 voids did this, they could combine into a single bubble that, from the outside, would look like one enormous empty region. Inside the Boötes Void, there are hints of structure that some researchers have interpreted as evidence of past mergers. Faint filaments of galaxies stretch through the inside of the void in certain places. These could be the remnants of walls that once separated smaller voids before they merged. In this picture, the Boötes Void is not a single anomaly, but a collective achievement of several more ordinary voids, who, through the gentle pressure of cosmic expansion, eventually opened the doors between their rooms and joined into one large hall. This explanation has a soft elegance to it. It does not require any new physics. It simply suggests that the Boötes Void is a community of older voids who became one. It is, in a way, a story about cosmic neighbors. The third lantern is the cosmic strings lantern. This one is more speculative, and we should be careful with it. In some theories of the very early universe, certain quantum field configurations, set up during the rapid cooling of the cosmos in its first instance, could have produced extremely thin, extremely dense thread-like defects called cosmic strings. These hypothetical strings would have stretched across vast regions of space, and their gravitational influence could have affected the distribution of matter in the early universe in ways that ordinary inflationary fluctuations would not. If a cosmic string were present in the early universe near what is now the Boötes Void, it could in principle have prevented matter from settling into a normal void wall pattern. It could have created an enlarged region of underdensity. The exact details of how this would work depend on the type of cosmic string, its tension, and many other parameters that we cannot directly measure. Currently, there is no compelling observational evidence for cosmic strings at all. The standard inflationary picture does not require them, and many specific cosmic string models are tightly constrained by observations of the cosmic microwave background. Still, cosmic strings remain a possibility. If they exist, even rarely, they could be one source of unusually large voids. The Boötes Void, in this picture, would be a kind of cosmic memory of a string that long ago dissolved, leaving its faint imprint in the empty geometry it shaped. The fourth lantern is the early dark energy lantern. In recent years, there has been growing interest in models that allow for additional periods of accelerated expansion in the early universe, beyond the inflation that everyone agrees about. Some of these models involve a brief surge of dark energy in the first few 100 million years after the Big Bang. Others involve modifications of gravity at very large scales. Each of them, in principle, could subtly alter the way structure formed in the universe. If there were extra accelerated expansion at certain scales or times, voids could become a little larger than they would in standard lambda CDM. The Boötes Void, in this picture, would be the natural product of such an enhanced expansion. Its size, instead of being a rare statistical outlier, would be a clue that some additional physics is at work. Many of these models are motivated by the so-called Hubble tension, the puzzling discrepancy between two ways of measuring the current expansion rate of the universe. We have explored that tension before, on another night. The Hubble tension may turn out to require new physics. If it does, that new physics might also make voids slightly bigger than expected, and the Boötes Void might become evidence that something subtle and unfamiliar is going on, something that would change our understanding of the cosmos. Right now, this is mostly a hopeful thought. There is no definitive evidence that the Boötes Void requires modified physics. But the void is part of a broader family of clues that scientists are watching carefully, like a small group of unusual notes in a long musical performance. The fifth lantern is the observational bias lantern. This one is a little duller, but very important. Astronomers cannot see all of the matter in the universe. We see galaxies because they shine. We see hot gas because it glows in X-rays. We see cold gas because it absorbs or emits radio waves. But there are many things in the universe we do not see directly. Dark matter, the dominant form of matter, does not emit light. Cold molecular clouds with no embedded stars are very hard to detect. Even galaxies themselves come in a wide range of brightnesses, and the very faintest ones are missed by most surveys. It is possible, in principle, that the Boötes Void contains more galaxies than we have detected. Perhaps it is full of dwarf galaxies, too small or too dim for our current telescopes. Perhaps it has dark matter halos that have not formed enough stars to be visible. Perhaps the void is not as empty as it looks. It might be, in some sense, hiding part of itself. This is a humble possibility. It does not deny that the void is underdense. Even with these hidden contributions, the void would still be less full than average. But it might be less unusual. Some of the apparent shock of 3% of expected galaxies might be softened if we counted the faintest ones we cannot yet see. Surveys with progressively larger telescopes have, over the years, found more and more galaxies in and around the void. Each new survey has tended to nibble at the edges of the underdensity, finding a few extra galaxies that previous surveys missed. The void has grown a little more populated with each generation of instrument. It has not, however, become full. The basic claim that the Boötes Void contains far fewer galaxies than expected has held up, even as telescopes have improved. So observational bias is real, but it is not enough to make the void disappear. The sixth lantern, the strangest one, is the speculative lantern. Here we will speak gently because we are entering territory that is more dream than data. Some thinkers have suggested that very large voids might be the imprints of extreme events at the boundaries of our cosmological understanding. One idea, for example, is that during a very early phase of the universe, our cosmos may have collided with another universe, like two soap bubbles bumping into each other in a sea of foam. Such a collision, if it happened, could have left a faint scar in the distribution of matter, a circular region where things are slightly different than elsewhere. Some researchers have proposed that the unusually cold spot in the cosmic microwave background in the constellation Eridanus might be such a scar. Others have wondered more cautiously whether the Boötes Void might also be one. This is not a mainstream idea. It is on the edge of what physics is currently willing to entertain. But it is part of the conversation, and it is part of why studying voids is interesting. They are large enough that if anything weird had happened in the very early universe, voids might be where we could find traces of it. There are still more speculative ideas, including the suggestion that very large voids might be artifacts of a simulation, or of some computational structure underlying the universe. We will not dwell on these tonight. They make for good conversation, but they are far from the kind of thing that anyone could test directly. They are mentioned only because they exist, and because the boundary of knowledge is sometimes a soft thing, with many fingers reaching past it in the dark. Take a slow breath in. Take a slow breath out. If we tally these lanterns, what do we get? We get a picture in which the Boötes Void is, most likely, simply a rare but allowed region of the cosmic web. It probably grew from an unusually deep, early underdensity, perhaps with some help from the merger of smaller voids. There is no compelling need to invoke new physics to explain its existence, although new physics is not ruled out, and the void remains an interesting testbed for ideas that might turn out to matter. It is, in other words, almost certainly real, mostly understood, and gently mysterious around the edges. That is a calm conclusion. It is not the conclusion of a thriller. It does not promise that the void will solve the deepest problems in cosmology. But it is honest, and honesty in cosmology is a kind of kindness. It is the kind of conclusion you can take with you to bed, and turn over slowly in your mind, and feel comfortable not solving completely. Most of the universe is full of galaxies. In one direction, in the constellation Boötes, there is an unusually wide stretch of nothing. We understand most of why it is there. We do not yet understand all of it. The work of understanding continues, in observatories and on computers, and in the long, quiet hours of researchers' thinking. None of it requires anything from you tonight. The understanding is taking place far away. You can simply rest. Each of these lanterns we have lit, the simple statistical one, the merger one, the cosmic string one, the early dark energy one, the observational bias one, the speculative one, casts a slightly different light on the Boötes Void. Together, they form a kind of low constellation around it, a soft, glowing ring of explanations that surround the central darkness of the void with many small flames. The void itself remains as it is, large and quiet. The lanterns do not illuminate it. They illuminate the people standing around it, who are trying to understand. That is what science often is. Not a single brilliant beam pointed directly at a mystery, but a slow gathering of small lights around its edges. With each new instrument, each new survey, each new theory, more lanterns are added. The mystery slowly becomes better understood, but it does not vanish. It is not a problem to be solved and erased. It is a feature to be known. The Boötes Void, in this sense, is not a problem. It is a feature of the universe. The universe has a feature, in the direction of Boötes, that is shaped like a hole. The feature is consistent with most of what we know. The feature is interesting. The feature is older than we are. The feature has been there for as long as galaxies have existed, and it will be there for as long as galaxies exist in the future. Take another slow breath. Picture, if you wish, the lanterns. Picture them as small, soft, yellow lights set in a wide ring around the rim of the void. Picture the dark inside the ring, full of the few patient galaxies we already imagined together. Picture the people on Earth, far from the void, looking through their telescopes, slowly adding more lanterns year by year, generation by generation. It is a peaceful image. There is one more thought worth holding before we move on. Some of the most thoughtful work on the Boötes Void has come not from any single dramatic theory, but from the slow patient labor of testing whether the void is consistent with the standard model of cosmology. Researchers have run very large simulations of universes, with parameters tuned to match what we measure in the cosmic microwave background and in the distribution of galaxies. They have generated thousands of mock universes, each one starting from slightly different initial conditions, but obeying the same basic physics. In these simulations, they then look for voids of the size and shape of Boötes, and they ask how often such voids appear. The answer, in most modern simulations, is that voids of the Boötes scale appear roughly as often as we would expect, given the size of our observable universe. There is, perhaps, one such void, or maybe two within the volume we can see. Sometimes the simulations produce slightly fewer than observed, sometimes slightly more. The numbers are sensitive to many details, but the general picture is that the standard model can produce a Boötes void without any significant strain. This is a quietly reassuring result. It means that the existence of the Boötes void does not, by itself, force us to invent new physics. It does not break any of our most successful cosmological models. It is unusual, but not unprecedented. It is rare, but not forbidden. The universe, with the laws we currently know, is allowed to contain a Boötes void. And it does. That said, the void remains a useful test case. As our simulations become more detailed, and as our surveys of galaxies become more complete, small discrepancies could emerge. A void that turned out to be even larger than we currently estimate, or a void that contained even fewer galaxies than expected, or several voids of similar size in nearby parts of the sky, might begin to push against the standard model. The Boötes void is the most famous example of a class of objects that cosmologists watch carefully, looking for the soft hints of physics we do not yet know. In this sense, the void is doing a quiet job for science. It is not solving any problems on its own. It is simply being there, large and empty, patient and old, while researchers measure it and remeasure it, and ask the same gentle questions in different ways. Each new generation of telescopes brings a slightly clearer picture. Each new survey adds a few more data points. The void does not change. We change slowly as our instruments improve. There is something restful in that, too. The patience of a feature that has been there for billions of years, calmly waiting while we figure out what to make of it, is a kind of cosmic hospitality. The void does not need our explanation. It does not require our story. It is simply what it is, and we are welcome to look at it for as long as we wish. In the next part of our journey, we will think about what it all means in the gentlest possible way. We will consider what it is to live in a universe that has rooms this empty in it. We will consider how to feel about that. We will not arrive at any final answer. We will simply stand together at the edge of the void, near our small ring of lanterns, and look one last time at the cool, calm darkness inside. Part 6. A hole in the universe. A hole in us. The night is deep now. You may already have begun to slip toward sleep. If that is so, you do not have to fight it. The story will continue around you like a soft lullaby, and you can come back tomorrow or another night to hear the parts you missed. We have stood for some time at the edge of the Boötes Void. We have learned how it was discovered. We have walked through its size. We have understood the cosmic web around it. We have visited, in our imagination, the small ghostly galaxies that live inside it. We have lit a ring of lanterns made of theories and possibilities. We have done all of this in calm and patient stages, and we have not hurried any of it. There is one more question to sit with, very gently, before we turn off the light. What does it mean for us, in our small lives, that the universe has a hole in it this large? The honest answer is that, in any practical sense, it means almost nothing. The Boötes Void is so far away that nothing inside it will ever affect your life directly. Its few galaxies do not nudge our planet's path. Its empty interior does not influence our weather. Its existence does not change the colors of the stars in your local sky. Tomorrow morning, when you wake, the void will not have moved noticeably closer or further. It will simply continue as it has for billions of years, doing nothing, holding its quiet shape, while everything ordinary in your life unfolds as usual. But meaning does not always live in practical effects. Sometimes it lives in perspective. And the Boötes Void offers a particular kind of perspective that, if you are willing to sit with it, can be a very gentle gift. Begin with this. The universe, on its largest scales, is mostly empty. Even outside the great voids, the regions of cosmic space between galaxies are far emptier than anything we have any everyday experience of. The space between stars within a galaxy is far emptier than the air around you. The space between galaxies within a cluster is even emptier still. And the space between clusters, between filaments, between all the structures of the cosmic web, is emptier yet again. By the time you reach the inside of a void like Boötes, you are in some of the most truly empty space that exists. There is, on average, less than one atom of hydrogen per several cubic meters of intergalactic space. There is barely any matter, barely any energy, barely anything at all. This emptiness is not a flaw. It is not a mistake. It is not something gone wrong. It is the simple statistical truth of how the cosmos is shaped. The matter in the universe is concentrated into walls and filaments and clusters because gravity has spent 13.5 billion years pulling it that way. The emptiness in between is what is left over. Voids are not subtractions from a fuller universe. They are the natural result of a universe that organizes itself into clumps. When you look up at the night sky, almost everything you see is empty. The dark between the stars is empty. The dark behind the stars, all the way out to the cosmic background, is mostly empty. The universe has decided, gently and without any consultation, to be a quiet place. The Boötes Void is simply an unusually large local example of this general truth. It is a place where the universe got more room than usual to be empty in. It is a place where the cosmic web allowed itself one especially deep breath of nothing. Take that thought into your body for a moment. The universe is mostly empty. The Boötes Void is just a very wide expression of that emptiness. It is not strange. It is not an enemy. It is part of the same gentle background of nothingness that surrounds every star we know. If this is true, what does it mean for us? It might mean, if you are willing to consider it, that you are a small, warm, dense thing in a universe that is mostly cold, mostly empty, and mostly quiet. You are an exception. You are an island of complexity. You are a place where matter has gathered into something able to be aware of itself. Most of the universe cannot do this. Most of the universe is too sparse, too empty, too cold, too still. Only in the rare warm places, where stars have formed and gathered into galaxies, where planets have formed and cooled into surfaces, where chemistry has run long enough to produce life, where life has run long enough to produce minds, only there can the universe see itself. You are in this small bed tonight, one of those rare places where the universe sees itself. The Boötes Void is the rest of the universe, in a sense. It is the long, quiet stretch of cosmos that does not see itself. It is where the universe simply is, without any notice. To exist as a tiny, conscious being, in a galaxy that did not have to be habitable, in a planet that did not have to develop life, in a body that did not have to know it was there, is a quiet improbability that we tend to take for granted. The void is a way to remember it. The void is a long, long, long stretch of universe in which there is, as far as we know, no being thinking anything. Most of the cosmos is like that. Some of the cosmos, here and there, is not. You happen to be in one of the places where it is not. That is not a reason for pride. It is not a reason for fear. It is, perhaps, simply a reason for a slow breath and a soft smile. There is also, in the existence of the Boötes Void, something that can ease certain kinds of human worry. Sometimes, when we think too hard about our small lives, we feel that the universe is full of expectations of us, that there is some great cosmic weight pressing down on whatever we do. The void is an antidote to that feeling. The void does not expect anything. The void does not even know we are here. The vast majority of the universe is quietly indifferent to us, in the most loving sense of the word indifferent. It is not against us. It is not for us. It simply is, and it is, almost everywhere, very empty. Whatever you did today, whatever you forgot to do, whatever you said or did not say, the void has not noticed. It has been going about its business of being a whole for hundreds of millions of years longer than any human language has existed. By the time anything we do today reaches the inside walls of the void, in the form of our radio leakage and our distant starlight, we will be long gone. The void will receive a faint trace of us, perhaps, much later, and it will not understand what it is receiving, because it has no way to understand anything. The void is not paying attention. This can be a comforting thought on a bad night. The largest features of the cosmos do not measure your day. Your day is measured by you, and by the people who love you, and by the small structures of your life. Those measurements are real. They matter to you. They do not matter to the universe at large. The universe at large is doing other, bigger, slower things. It is making galaxies cluster. It is making voids drift. It is making everything expand a little more every second. It is, on the whole, busy with its own immense quiet work, and it has no time for the small concerns of any one breath. You can let your small concerns be small. You can let them belong to your day and not to the cosmos. The cosmos has its own concerns. They are mostly nothing. There is one more soft thought before we close this part of our story. Inside the Boötes Void, far from us, is a small constellation of galaxies that we have detected over the decades. Inside one of those galaxies, there may be a planet. Inside that planet, there may be life. Inside that life, There may be something that thinks in some way that we would recognize, even faintly, as thought. We do not know if any of this is true. The numbers are very small, but they are not zero. The cosmos is large, and even the inside of a large empty bubble might contain, here and there, a rare warm point where minds have grown. If such a mind exists inside the Boötes Void, it lives in a cosmic neighborhood very different from ours. It looks up at a sky that is, for most of its history, empty of nearby galaxies. It might have spent many of its centuries believing it was alone. And then, perhaps, it built the right instruments, and it began to see the faint smudges of distant galaxies far across the void, and it learned, as we learned, that the universe is much larger than it had imagined. If such a mind exists, it is your far cousin, not by genetics, but by something simpler, by awareness, by the strange shared condition of being a brief, warm island of thought in the long, cold sea of cosmos. We will probably never meet. We will probably never even know about each other in any direct way. The void between us, both literally and figuratively, is too wide for that. But for one small moment tonight, you can imagine that mind, and you can imagine that mind perhaps imagining you, and you can let the two of you, separated by hundreds of millions of light years of nothing, share a single quiet thought across the darkness. The thought might be something like this. Whatever this is, whatever we are doing here, whatever the universe is up to, it is large. It is largely empty. It is mostly quiet, and in the few warm, bright places like ours, like maybe theirs, there are small sleepers lying in small beds, listening to small voices, drifting toward small sleeps. We are not what the universe is mainly made of. We are exceptions. We are fortunate. We are quiet companions in a vast, deep dark. Sleep well. Sleep well in your small warm place on your small warm planet, in your small warm galaxy, in your unusually crowded patch of the cosmic web. Sleep well while the Boötes Void continues to hold its quiet hundreds of millions of light years in the direction of the Herdsman, slowly drifting along with the rest of the universe, holding its few patient galaxies, knowing nothing of you and asking nothing of you. The universe has a hole in it. The hole is large enough to swallow most of what you can see when you look up at the night sky. The hole has been there since long before the Earth was born. The hole will be there long after the Earth is gone. But the hole is not unhappy. The hole is not lonely. The hole simply is. It is a feature of the cosmos, like the rings of Saturn, or the dust lanes of the Milky Way, or the cold of intergalactic space. It is part of how the universe shapes itself, and you are part of how the universe shapes itself too. You are a tiny, dense, warm, breathing piece of cosmos, lying in a bed, listening to a story about something far away. You are the universe doing one of the rarest things it does. You are the universe being aware of itself. It is enough. It has always been enough. It will always be enough. Tomorrow, the Boötes Void will still be there. The cosmic web will still be there. The galaxies will still be there. Your bed will still be there. Your day, with its 1,000 small things, will still be there. Tonight, none of that has to happen. Tonight, you can simply rest, while the universe goes on without you, and the void holds its place in the dark. Let your breath grow softer. Let your hands lie heavy on the bed. Let the long thoughts of the day grow distant. There is one last image we can carry into sleep if you would like one. Imagine, very softly, that you can see the whole observable universe at once. Imagine you are a very gentle observer, suspended somewhere outside it, watching the great pattern of cosmic structure unfold like a piece of slow lacework. You see the bright, shining concentrations of superclusters. You see the long, luminous filaments stretching between them. You see the thin walls of galaxies tracing out the geometry of foam. You see the great, empty rooms in between, the voids, large and small, patient and silent, distributed through the structure like quiet pauses in a long piece of music. In one part of this view, you see a slightly larger empty room than the others. A bubble, a hush, a soft circle of darkness in which a few faint galaxies float, like lanterns lit on a still lake. That is the Boötes Void. That is the place we have been visiting tonight. That is the wide, quiet feature of the cosmos that, until very recently in human history, no one knew was there. Now imagine a small, bright spot, very far from the void, near another corner of the lacework. A single, tiny pinpoint of light, marking the location of one particular galaxy. Inside that galaxy, on one of its outer arms, is a small star. Around that star is a small planet. On that planet, in a small room, lies a small body, breathing slowly, listening to a quiet voice telling a story about a hole in the universe. You are that small body. The voice telling the story is mine. The story is almost over. It does not have to end with a conclusion. It can end the way many old stories end, simply by trailing off, gently into the dark. The void will continue to exist. The galaxies inside it will continue to turn. The walls and filaments and clusters of the cosmic web will continue to do whatever it is they do, on their own slow timetables. None of that needs anything from you. None of that needs any of us. You can rest now. You have been thinking for several hours about something very large and very quiet. You have stretched your imagination across hundreds of millions of light years. You have visited, in your mind, the inside of a place no human will ever go. You have lit a small ring of lanterns in your own mind, around a feature of the cosmos that, until tonight, you may not even have known existed. That is a worthy night's work. That is plenty. Now your work is done. Now you can let the void be the void. You can let the cosmic web be the cosmic web. You can let the galaxies be the galaxies. You can let yourself be yourself, lying in a small bed, in a small room, in a small house, on a small planet, in a small corner of an enormous universe. The universe does not need you to do anything else tonight. Sleep is allowed. Sleep is welcome. The Boötes Void has been there for a very long time. It will be there in the morning. It will be there next week. It will be there next year. It will be there long after this voice is silent and this story is forgotten, and the planet you live on has spun 1,000,000 more times. For now, all you need to do is breathe in, and out, and in, and out. The universe takes care of itself. You, here, in this small warm place, do not have to take care of any of it. You only have to rest. Good night. Good night, gentle listener. Good night, small warm exception in a mostly empty cosmos. Good night.